Okay, thank you.
Okay, so for those of you that don't know me, my name is Randall, and this is my first Nova meeting, so major fail there. I'm around a lot of different places. You may have seen me at ShmooCon give my talk about a big grand overview of Bro and Bro-IDS. You can find me on IRC all day long almost. I'm usually in hashtag Bro, which is the new domain for bro.org, which we just cut to last week. My email address is now liam@bro.org, which is the coolest email address I've ever had. And
there? Don't tase me.
Don't tase me, bro. At the Brilliant. Brilliant. A couple of notes. If you'd like to follow along, you can go to bro-ids.org or bro.org and git clone the repository. There's also resources already online, and there will be a new media section on our website soon where you can come to find training videos and so forth. My personal GitHub is listed there, and we should be ready to get started. The first thing I wanted to talk about was there is a massive interest in Bro right now. So along with Scott Reynolds, who's actually here today and an existing member, we've offered to start doing some Bro training classes. So if you're interested in that, up on the Nova InfoSec portal, I went ahead and I think I followed the instructions properly and set up the sign-up sheets. Starting next month, if it's available, on the Tuesday after the meeting, we'll get together in the evening, we'll do some Bro programming crash courses. Now, I can't promise that I'm going to turn you into Bro B1 Kenobi overnight, but I think the general idea... I think the general idea...
I'll throw it right here.
Boo! I think the general idea is that Bro-IDS is awesome and amazing, but the big thing to be excited about is the Bro network programming language. I deserve that. I deserve that. So ultimately, what I want to hear back from you over the next month is, I feel like there are two distinct needs here. We need some Bro administration classes. The online documentation is great, but so many people learn better by example and through being shown something than they do by just reading about it in a book. And then we also need more Bro programmers. So what I'd really like to do is for you guys to figure out what you want to do, and my thought is maybe we'll take like a protocol or a class of attack, and we can sit down and just do some crash courses and say, okay, how do we write a detector for DGAs, domain generation algorithms, in DNS? How do we write a detector for, if we want to stick with DNS, we could do like DNS amplification attacks. And then what we could do is we could write these little scriptlets, and then you can take that back into your organization and then start to do things like lock things down in Bro. Scott Reynolds is working on a nice user manual for Bro. The website is awesome, and if you want to get started tonight, you can't wait. There's this great workshop from 2011 that you can go through that takes you through the basic grammar of the Bro network programming language, the basic data types, how to run Bro from the command line, and go from there. There's also resources throughout Git. I think now we're the 77th or 78th most popular language out of 87, but we are rapidly climbing. I can remember back when we were 83, so many years ago. So if you'd like to follow along today, the stuff that some of the things that we're going to be talking about are actually not in the Bro 2.1 that's released in Security Onion or was in the main repo. But all of this is committed actually to the master repository. So if you really want to get into Bro, you need to learn a little bit about Git. And there's a great quick start walkthrough right here. So you can pull down some of these things that are ready, but don't get put into Bro production until they're ready for Bro at 10 gigs. That's what the 2.1 code is. So this is, and the other caveat is that this is my way to teach everything. It's definitely not the only way. And I'm really trying out new material on you guys to see what works and what doesn't work. And note to self, no more Star Wars jokes. So today what I thought we'd talk about is Intel application. There's a lot of Intel out there in the world, and I honestly believe that Bro is the best way to consume and apply Intel in your organization. So what I mean by that are, when we think about some of the Intel that would be appropriate from a network context, would be addresses, subnets, domains, file hashes, all the usual things that you would see in a signature. What differentiates the way Bro does it is, because you get all of these protocol level events as the language flies along, you can actually look deeper into the protocols. Instead of just looking for a domain on your DNS request and reply, why not look inside the HTTP host header? Why not look within the SSL certificates themselves for all the information that's included in there? So what we're going to do is we're going to break this down into 4 different problems. That's how I find it in my mind. One is, how do we use the intel we know? The second is, how do we generate new intel from the traffic that's on our wire and on our network now and feed that back into Bro? What are we doing beyond intel, and then what does the future hold for us? So let's go ahead and get started. So when we talk about applying intel here, we have all these things, and for each one of these protocols, I don't want to go through each one because I think you guys get the general idea. We should really be looking for all of these other triggers like domains in things like your emails. When you get an email, when it comes across the wire, when you can see all the data, why not scan it for all the DNS names and look to see if you have any matches within those messages? It's a great technique, and right now a lot of the other test tools out there just do not give you a complex enough inspection into these objects that are on your network. So the general idea is that across each layer of the protocol stack, from down at the connection layer in TCP, UDP, ICMP, to DNS, HTTP, SMTP, and SSL are the examples that I'm going to show you today, we want to detect all the things, take all of our different intel and look at it in all the different places. And where this is done in Bro is something called the Intel Framework, which is included in that Git master repository. And you can start to play with these things now. I hope that you'll see in a very immediate use case for these things when we get into this a little bit further and we talk about sucking the intel out of your data as it's coming across the wire, feeding it back into Bro, and then watching for one of your users to trip that data. We'll do an example in a minute. The other thing I like about Bro is not only can you take all the intel that you currently have, but you can detect it everywhere. I have the privilege of working on some very interesting networks, and in some of these networks we'll have many layers of traffic. So this is an example that I actually also showed at ShmooCon. This is from a telco network actually, and what it is it's 802.1q tagged traffic off the towers that speak IPv6, and then there's a UDP stream embedded in that, encoding a GPRS tunnel, which is it contains IPv4 data. So this would be what your cell phone is actually on right here. And then it gets even better because some Windows laptops and Windows 8 will have Teredo enabled, which will automatically try to tunnel your IPv6. So then on top of that, you'll even have an IPv4, then a Teredo tunnel, and then IPv6. And then within there, you have your HTTP events or your SMTP events. And the great thing is Bro doesn't care. It will pop every single one of those layers off, and you still just see your HTTP event or your DNS reply or your DNS request. So you can take that intel and test it at all the places in your network, wherever your key tapping points are. So I think consuming and testing intel is pretty understandable, so I don't want to spend a lot of time on it, although we're going to do some actual examples in Bro here at the end. What I think is more interesting is to think about extracting data out of your network in real time and feeding it back into Bro. And so there are some real interesting use cases for this. And if you're not familiar with Bro, by show of hands, who saw my ShmooCon talk? Okay, so if you're not familiar with Bro, you have all this traffic flying across the wire here, and you'll drop it in a tap. Bro sees all the things, and then these events fire off. For each protocol, it tracks state across the entire TCP/IP stack. So for these protocols in particular, and in addition to these, also SSL TLS, there's all kinds of data that is exposed. The example that I used earlier was SMTP, and I think that is an easy one to start to look at. Because what you can do with Bro is, because you can extract data from one protocol, say an email, SMTP, feed it back into Bro, and then test it everywhere, you can very quickly in real time get multi-protocol heuristics. So if you think about an email that would come in with a domain name, and then somebody later clicking on that domain name and going out, that might be something that's worth detecting and alerting on. And I think the general use case for what we're talking about here would be a spearfish detector, right? Feed everything back into Bro. So the basic components of it look like this. You have all of your devices, and this isn't just all the devices in System Center or all the devices in that there's an agent for, or whatever the case would be. This would be everything that's speaking TCP/IP in your network. It doesn't matter where it's coming from, so long as it's speaking TCP/IP. It comes across Bro. the protocols that Bro can see, so it can't look inside your SSL TLS tunnels, but it can extract data about those X509 certificates as they're exchanged. But it can see into the DNS, HTTP, SMTP, FTP, and a bunch of other areas like that. So what you want to do is have Bro extract it all and then feed it right back in. Once it's back in and you get an alert, then you can do the things that I demonstrated in my ShmooCon talk, like take an action. When you see a certain type of event, why not go ahead and do something like update Twitter or move somebody to a remediation VLAN. These things are not just theory. They're actually very simple to do in Bro. This is all in Bro script land. This doesn't require tens of thousands of lines of code. So when we're looking at where we're pulling this data from, all of this intel is embedded. So this is pulling data back off the wire here. So an example that I have up on screen right now is an X509 certificate, which are exchanged whenever there's an SSL or TLS communication. So you'll see these on your email, on your regular websites. There's a DTLS, which is used, it's a UDP version that's used in SIP communications. You'll also see it on your VPN. So this is not just your traditional HTTPS web browsing stuff. There are sometimes email addresses in here in addition to domain names. So when you pull all of this information out of Bro, or off the wire, and feed it back into Bro, you can now test it. So this would be a two-way. First, when we read it, we'd say, is this on my to-watch list? And then when I see a new one, I'd say, is this on my watch list? If not, add it to this list to say that we saw a user click on this. Let's take a look at another example. I just kind of mentioned this. This is still a problem in 2013, which is really kind of crazy. And I think that we are very close as a community to putting forward some solutions that more effectively address this, and certainly more cost effectively, because Bro is open source and it's perfectly free. It's included in Security Onion. If you've never played with it, it's a wonderful product. So what I'm saying is that there's generally some lost knowledge that is not included here. And I'm certainly not talking about Joey. What I'm talking about are pulling all of these URLs and things right out of these emails and dropping them back in. Now, in addition to emails, and this goes not only to SMTP but to HTTP, there's also the ability to extract all the attachments in Bro. So you can pull file hashes. When you look at Mandiant's great APT1 report, there were all kinds of file hashes that were included there. Another great source is the Team Comrie file hash registry. So in Bro, and I put a separate video up on YouTube for this already, you can just enable some quick little flags and tell it to extract every file, or only files of certain MIME types, if that's what you decide you want in your network, out to a certain place on disk. You can also tell Bro on a per file type basis to calculate hash sums. So by default, I think it's doing it for executables only, which is great. And then if you enable an additional plugin, it will go ahead and look up every one of those hashes to the Team Comrie malware database. There are lots of other Intel sources that will eventually be integrated into that, I think. But it just starts to put those things forward into your mind. And there's lots of places, a whole thread we could go down this rabbit hole about, well, now that we have the files, why not JS unpack them or whatever? But I want to just keep this talk focused on just Intel and Bro. There's lots of other things we could talk about with that, though. Now, when you talk about file extraction, you could even get more advanced with it. So when we're talking about pulling Intel out of things off the wire, maybe in your network you only want to pull Intel out of the wire in certain conditions. Bro can use the MaxMind database to tell you the ASN that a connection is from. It can also use the MaxMind GUIP database to tell you what is the current location. So it is arguable whether those are effective metrics or not. I think that in certain circumstances they are. I know people that have had Intel hits on that they had an SSH login from someplace they'd never seen it before, and it prompted the investigation that eventually led to the discovery that someone's credentials were stolen. However, yes?
Do you integrate with Cuckoo?
Not yet, but soon.
What does that mean?
In 2.2, there's a new file analysis framework. And in the file analysis framework, there are these plugins. There's like a whole plugin architecture. So in Bro 2.2, just as Bro abstracts away the concept of protocols from ports, it dynamically detects each protocol in the wire as it sees it. It uses the port as a heuristic. Well, In Bro 2.2, there's a new file analysis framework, which abstracts the concept of a file away from a protocol that it was discovered on. So when we look at, a file may have come out of IRC or FTP or SMTP, you may not really care where that executable came from or where that whatever came from. You just want to do something with it. So there's a new event that's in there that there's an example up in GitHub that you can integrate right into Bro. We met with Tyler, the guy that did Mastiff, and the problem that we saw with Mastiff, to kind of go down this rabbit hole here, is he didn't have an easy way to like standardize his output back in. So since we had to do that anyway, we just started toying around with a couple different scripts to say, well, since we have to come up with the schema for how we take data back in from the output of all these different tools into Bro, we could do that. Because otherwise you're just going to generate data to an outside tool, which is a fine thing. And that, maybe you want to have Cuckoo just send you an alert when it detects all the things. I don't know.
No, I'm thinking more along the lines of, it sees this binary going to a domain, throw that back into Bro and say, hey, this domain is bad, right?
That is why I'm flying out here every month to talk to you guys, because you guys get it. And that is exactly where I think we're all going with this. And when you start to think about, wow, you mean all the pieces are really right here to build a $200,000 network magic box, and it's free, and it runs on commodity hardware? That sounds pretty impressive to me. I do want to get back to Intel, though, because I can talk about Bro all day long, and I'm really happy to. And I hope on lists we're going to sit down and come up with a list of topics and things that we'd like to cover. Maybe we want to play with the new file analysis framework and say, well, let's take the standard or the generic case of let's integrate one tool into Bro, and then unleash you guys, and you guys integrate all the things. That would be wonderful. That is actually the whole reason why I'm coming out here, is to find people that get it enough to want to build new knobs, right? We need more knob turners, that's certain, but we certainly need more people that can build knobs, and it's not hard to do in Bro. So when we're talking about enabling all this file extraction, there's a lot that we are already doing, and there's even more that we will be doing with it in the very near future. So to look in my ShmooCon talk, I called this the Bromus story, which would involve shooting my eye out with a BB gun. Instead, this should be the Bromus carol. This would be when you talk about Intel consumption, you have the past, the present, the future, and the things that may be. So when we talk about the past, these are things that we know is bad. So this would be like the lookups to the malware hash registry, comparison with all of your Intel sources that you're pulling into Bro. Active analysis would be exactly what we just discussed. I've Cuckoo box and volatility listed up here. But even things like JS unpack and feeding it back in. This is not like the distant future. This is the very near future that these things are going to be done. Long term, an example that I have when I go out and I consult with clients, I always ask them, do you have a place on your network where you have a copy of every executable? If you have to support that as your security team, do you have every version of every file that's been downloaded? Just executables. I'm not saying every file. That just seems like that should be pretty reasonable. Well, if you're already downloading it anyway, why not store it for long-term analysis? It would also give you the ability to support your products and understand what your users are doing. This is a derivative piece of Intel, but it's also interesting in Bro to throw an alert anytime somebody downloads malware bytes. Because even when it comes back clean, as it inevitably will do, that is essentially the user saying, hey, something isn't quite right here, right? That is something that you should feed back into Bro yourself to test on later. And then there's all sorts of predictive analysis. Long term, and this is not something that is, there's no working code that does this, but I think that you'll see Bro integrated into things like the Google malware service. No, not VirusTotal. Maybe VirusTotal, but they have their whole predictive analysis thing that they do in Chrome, and it's actually pretty neat. They use this technique or these data structures called Bloom filters, which a Bloom filter will never give you a false negative, but may give you a false positive. And what they do is when you're browsing the web, and you get a hit to maybe a bad site, if you actually look at what Chrome does, it actually double checks with Google and says, is this really a hit? And then comes back. so it's almost transparent to the user. So bloom filters are in process in Bro right now. So, but there are all these interesting things that we're gluing together now, and Bro is a great place to do it because it's not just the Windows boxes, or it's not just the things running a web browser, right? My big problem with a lot of the Intel things that are out there now, when you look at SSL TLS, certificate pinning, for example, like certificate patrol or whatever, is that they only work in certain use cases. It's great that you can test, your SSL certificates for your web browser. That's really convenient. But can you do it on all of your devices that are speaking HTTP? Can you do it for all your business processes that are, doing $1 billion a year with your suppliers through Ariba? Are those things that you should be looking at? And when you look at, am I actually doing my job and using all this intel that I have as effectively as I could be, I would argue that if you're not using Bro, you're not. Just put it out there. All those paid downloads I get. Yes?
So is the data being sent to all these external services, or is that like functionality that Bro is working with these other companies to build into? The question was, is the data being distributed to these other services or not? And for example, if you enable the Team Comrie malware hash lookup, the hash of the file is sent. So you are leaking information. So even if they have a miss, like let's say that the hash is 10, and 10 is not in their database, so it doesn't come back, you have essentially told Team Comrie that you have a file hash that is 10. So there is derivative intel that's leaked. Now, you have to enable that in Bro. You have to actually go in and you just @load the Team Comrie malware hash lookup. All right, so that's not something that's done by default. Go ahead, question.
How does that fit in with like the FSI stack?
So there are different groups that distribute their own intel that are fed to them from other organizations. A great example when you talk about the ISACs would be the Ren ISAC, and I'm actually going to get to intel sharing in just a second. The Ren ISAC, let's just hold on, I'll get to it in just a second here. So when we talk about intel, one of the major problems that everyone seems to be having now is, how do I share my intel? And that's a big problem, as the young lady in the back just mentioned, that you're essentially telling people things about your network that you may or may not want them to know. Ren ISAC is a great example. The Research and Education Network ISAC is essentially the group of high-end EDUs, government labs, and DOE facilities that are all connected in the next generation internet, working on real core research projects and everything like that. The NSF has funded a project called CIF, the Collective Intelligence Framework, that acts as a central clearinghouse for those groups that are cleared into that program for them to exchange data. And what CIF does is it actually gives you the ability to accept multiple data from multiple inputs, apply some heuristics to it, like, do I trust this data source, or at what confidence interval do I trust this data source? For example, if I submit it to it personally, you may want to tag that with a confidence interval of 10. And then as other people submit that same intel, maybe you would add it up to a higher score and eventually would cross your threshold where you say, well, everything that has a confidence interval above 75%, go ahead and write me a rule or suck this right into my Bro sensor. CIF is a great project. There's a lot of wonderful ideas and knowledge in that project. And it actually will also write out to Snort for you. There's a plugin up on Git to go ahead and have it write out to Bro, which would test it in some different places, and so forth. And it's pulling all the open source intel as well as some private feeds that they have in there. Another example of shared intel would be the International Computer Science Institute just spun up an SSL observatory. And in that case, what's happening is that for every SSL certificate that comes across, a SHA-1 hash is generated, and this server is queried over DNS, and it passes back, and it tells you the first time that this certificate was seen and some other interesting intel that you may or may not want to know about. So if in your network, if you see a certificate that no one has ever seen before, maybe that's something that you decide is important and should just be looked at. When you look at some of the other examples, and I put up, if you go to my YouTube channel, there's a couple of videos that actually talk about SSL TLS problems. And I've got some more videos coming out to talk about how you can pin certificates and things like that, and whitelist CAs and blacklist CAs. That functionality was only enabled last week, so that's something new and fun to talk about. So we talk about sharing intel.
Git is actually a great way that people are sharing intel now. Within about 24 or 48 hours of the Mandiant APT1 report, Seth Hall had released a quick little module here that you could download right into Bro. There are also lots of other people that are sharing intel and even heuristics, or those things beyond intel that you can detect in Bro. I've listed 3 of my favorites right here, but there are a couple other sources that you should check out online. And I anticipate that those sources growing significantly as the Bro community gets larger in the next few years. Yes?
So for the modules, are they something that's compiled to where you can get the information out of them, or can you actually look at the module and say, okay?
You get the code.
Mm-hmm.
You get the code.
Okay.
The question was, are the modules compiled, or can you look at the code, essentially? Right now, there's not a method in Bro to conceal your scripts. You know, everything is open source. You see it all there. There's a difference between the stuff that's running up here in script land and the core analyzers that are compiled in another language. But everything that's in script land you can see. So they're great examples of how to implement Intel testing in Bro as well. Are there any other questions right now? Okay. So real quick to review, when you talk about Intel sharing, I see this on a regular basis with larger clients and larger organizations, are that organizations do not share intelligence with themselves. The left hand does not know what the right hand is doing. And I've actually seen the same compromise at 2 different places in the organization that was detected in one place and not detected in the other. So one of the things that I recommend that people do is to share intelligence with themselves. A couple minutes, I'll be done. So when you look at some of the things that Bro can do, for example, you can append ASN and GeoIP data to your logs. Are you running protocol metrics on your existing logs now and feeding that intelligence back into Bro? Are you setting thresholds and saying that even beyond the simple intelligence of, you know, maybe not simple intelligence, but intelligence like DNS names, are you doing metrics intelligence and things along those lines, or measurement intelligence rather? So Know Thyself was my second slide choice there, which the first one I'd inadvertently written in was how to play with yourself, and that obviously should not be up on the screen at all. So if you'd like to know some more examples, there are more videos on YouTube, and there are a lot more coming. Mateus wrote these things called the customization points in Bro, which are simple little one-liners you can drop into your security onion sensor that you've got set up to enable a lot of this functionality and tweak it to your own network. But I think ultimately it would be kind of incomplete to say, well, what about moving beyond the idea of Intel? And I've thrown this up here a couple times, and I'll probably put it in every talk somehow. I'll try to work this in. But I really think that the bigger point with Bro is that you can do signatures in Bro, and you can do them better than you can do in some other solutions. But that for every signature hacking away at the leaves of evil, there's a greater heuristic striking at its root. And I'd like to just show you a quick example of this so you kind of understand what I'm talking about. When we talk about things like a multi-protocol heuristic detector, in that Lucky 13 attack, I posted the code, a detector for it is written and up on my GitHub, but that's that new SSL TLS attack. And when you look at how you develop and write those attacks in Bro, it's actually pretty simple. There's all this incredible low-hanging fruit that people are sometimes distributing as Intel that really could be taken care of in a broad swath with indicators. An example that I like to talk about are things like the configure worm, okay, or the virus there. One of the reasons it's been so persistent has been that it uses domain generation algorithms. So instead of looking for a static DNS name that is then proxied to, you know, fast flux, perhaps even to hundreds of IP addresses, every day it uses an algorithm to generate 10,000 new domain names. And to prevent the blue team from sinkholing all of their domain names and then taking control of the command and control infrastructure, it only has to find one valid command and control server out of those 10,000 to continue and connect back and go on. It's very persistent. When you actually look at PCAPs of this on a network, what do you think is going to happen when you have 10,000 attempted DNS requests and one reply? It stands out like a sore thumb when you look at it on the network. So I really think that it would be more effective for us as a community, instead of playing digital whack-a-mole with some of these problems, to sit down and implement some simple heuristics and knock these things out once and for all. If we have another couple minutes, I wanted to show you guys some code. If we're out of time, we have time. Great. So let's do a quick little bro script. This is HTTP brute forcing. This is commonly seen on networks as a precursor to a larger attack. Probably something you should be watching for. So if you're going to run like dirbuster, you could write a signature for dirbuster really easy and look at the user agent, and you can detect that in bro, and you could say that if the user agent equals dirbuster, I'm under attack. But I think we can all agree that that's perhaps not the most effective way to detect that kind of attack. So if we want to quickly brainstorm a way to detect that, we would sit and think about what are we going to see when we're seeing an HTTP brute forcing attack. On the server side, we're going to see a high rate of 404s. On the client side, we're going to see a high rate of 404s. What about different use cases like a distributed scan or slow scans?
How about just detecting on the first 3 keys in the dictionary for dirbuster?
The first 3 keys?
Right. So everyone uses dirbuster uses the same dictionaries. So take the first 3 of them and say, okay, this is dirbuster.
Well, that is, I think that would be an example of a signature threshold. And I let's see, did I put that on? Oh yeah, could we track invalid URIs? And I thought that would essentially be another whack-a-mole case. I'm looking for what is the greatest, how do we solve this once and for all, right? Let's just kill it all together. Now when you're programming, if you will, when you're brogramming, you want to keep in mind, if you can't beat them, join them. You want to keep in mind that all of your libraries are these cluster safe metrics already. So the code you write to run at on your 1 gig connection in your office will also scale with this utility model in Bro right to 10 gigs. So you want to think about when you design these things, what's the most effective way to address this problem? So in this case, after looking at it for a little bit in testing, I was like, well, let's just look at the status codes. Now we need to keep in mind that just because something's throwing a lot of 404s doesn't necessarily mean that it's under attack. But what it does mean is that maybe there's an anomaly that should be looked into here. Let's see here. And this is all up on GitHub right now. If you want to look at it, you can pull these scripts in PCAPs. So I wrote 2 different versions of this. I wrote one as an example of the language, which is actually not cluster safe. And then I wrote one version that is the cluster safe way. I wrote the one that is not cluster safe to show you guys some examples of the grammar of the language. How do I iterate through arrays? How do I build arrays of arrays? How do I build arrays of arrays of arrays? So what we're essentially doing here is we've got some global variables here, and we're going to set some thresholds. We're going to say whenever we see more than 30 404s from one of my clients, over a certain period, let's go ahead and just fire an event. So in Bro, this is the essence of brogramming right here. You just hook an event, and you can hook an event as many times as you want. So here I'm just hooking the HTTP begin entity event. And I don't need to worry about how it's encoded on the network. I don't need to worry that it's tagged and tunneled and whatever else. Bro just serves all this up to me at a very high level here. And what I'm doing here is I'm basically just going to start counting the number of server requests that I'm doing. So what I have some example PCAPs here. Let's see here. Okay, so I'm just going to call Bro in and tell it to read a PCAP here that I have. And I'm going to first launch it with my Bro script that's called HTTP status codes with client-bro. And what it's going to do is it's just going to count all of the number of 404 errors, and then it's going to write out the screen here and tell you that this server, and I decided on the server side not to track my servers by IPs because a server could host multiple servers on it, websites rather, to go ahead and track it by the server name. So here, www.example.com had